Hello and welcome to note quiz number 7, which is titled The Algebra of Functions. In this note quiz, we're going to talk about symmetry, we're going to talk about even and odd functions, talk about how to do the algebra functions, which is adding, subtracting, multiplying, and dividing, and finally, composition of functions. So let's start off with first talking about symmetry. The idea is to think about what properties graphs will have with regards to symmetry, which means being able to divide them into equal parts when you look at a line of symmetry. So for the first one, we want to replace negative x in place of x and see what we get. So if you take a negative x and put it in place of x, that's going to give you y is equal to negative x squared plus 5, which just turns into x squared plus 5. So because of that, you're going to see that this function is the original. So therefore, it's going to be symmetric over the y-axis. Now let's check the x-axis. To do that, we will look at negative y going in place of y. Making that substitution, we have negative y equals x squared plus 5, which implies that y is equal to negative x squared minus 5. That is not the original. So therefore, it is not symmetric over the x-axis. And finally, let's do the origin. For the origin, we're going to have both negative x going into x and negative y going into y. Putting those together, we've got negative y equal to negative x squared plus 5, which turns into y is equal to negative x squared minus 5. So this function is not the original. So it's not symmetric to the origin. So we just have symmetry with respect to the y-axis. And if we think about the graph of this function, that would make sense because it's just a parabola that is going to be up here, up at 5. And it is nicely symmetric over that y-axis. All right, for the next problem, let's take a look at x is equal to the negative absolute value of y minus 2. First, let's go through and do these in order this time. So let's do the negative y in place of y. So if we substitute negative y in place of y, that's going to give us x is equal to the opposite of the absolute value of negative y minus 2, which just simplifies down to the opposite of the absolute value of y. I said y, not x. Y minus 2. And that is the original equation. So because of that, we see that we have symmetry over the x-axis. Now let's take a look at the symmetry over the y-axis. Negative x going in place of x gives us negative x is equal to the negative absolute value of y minus 2. Multiplying both sides by the negative gives us x is equal to absolute value of y plus 2. That is not the original function, so it is not symmetric over the y-axis. Finally, let's check our origin. Again, that's taking negative x in place of x and negative y in place of y. Putting those together, we've got negative x is equal to the opposite of the absolute value of negative y minus 2. That's going to give us x is equal to absolute value of y plus 2. Again, that is not the original function. It's the opposite of it. So it is not symmetric over the origin. We just have symmetry over the x-axis. Last but not least, problem 3. We first substitute in our negative y in place of y. That's going to give us x to the 4th equals 6 plus negative y squared. That simplifies down to x to the 4th is equal to 6 plus y to the 2nd power, which is the original. Therefore, we have symmetry over our x-axis. Now let's check symmetry over the y-axis. If I substitute in negative x in place of x here, and I still have the 6 plus y squared here, that turns into x to the fourth equals 6 plus y squared, which is again my original. So I'm symmetric over the y-axis. And then finally, check the origin. Negative x goes in place of x. Negative y goes in place of y. Putting that together, we end up with negative x to the fourth equals 6 plus negative y squared. Raising the negative to the fourth power keeps it positive. Squaring the negative y keeps it positive. That's the original equation back again. So we also have symmetry over the origin. So that last one actually has all three symmetries, which is pretty nice result for graphing. All right, so let's move on to the next page. For these problems, we want to look at even and odd functions. And the even function says if you take f of negative x, you get f of x. And what that means is the values for the positive x values match the values for the negative x values. For an odd function, f of negative x equals negative f of x. That is symmetry through the origin, more of a reflective kind of symmetry. So let's go through now and check out these different functions that we have to work with. For letter number 4, we'll calculate g of negative x. That's going to be the opposite of negative x to the 8th plus negative 9x in absolute values. Okay, so plus absolute value 9 times negative x, like so. All right, so if we take a negative x and raise it to the 8th power, it's a positive x to the 8th. But there's still a negative sitting in front. We know that the absolute value of negative numbers is always positive, so that's going to be the absolute value of 9x again. And you'll notice that is the same as the original function. That's equal to g of x. Therefore, we've got ourselves an even function. All right, now let's take a look at the next problem. We're going to take a look at h of negative x and see what we get. That's negative 2 times negative x to the third power plus 4 times negative x. Raising a negative x to the third power gives us a negative x cubed. So that's negative 2 times negative x cubed minus 4x, which is 2x cubed minus 4x. You will notice that is the exact opposite of the original function. So because of that, we're going to end up with an odd function. Again, if you take h of negative x and get negative h of x, you have yourselves an odd function. Now let's take a look at the last example on this page. We're going to take m of negative x once again. That's going to be 7 times negative x to the third power plus 9 times negative x minus 5. And you will notice that if you take a negative x to the third power, that's 7 times negative x cubed minus 9x minus 5, which is negative 7x cubed minus 9x minus 5. You will notice that this is not the original function because the signs are off. You will notice that it is not the opposite of the function either because not all the signs are reversed. If we factor out a negative 1, we get 7x cubed plus 9x plus 5, which again is not the original function. So in this case, we have neither an even or an odd function. We have just a regular function without that classification. All right, let's move on to the next page. For the next page, we want to evaluate a piecewise function. And when you're doing this, you're always looking at how the x number in the function notation compares to the inequalities on the right side of the definition of the function. So in particular, when x is equal to 0, I'm going to use the middle part of my function and evaluate it with that part of the formula. So h of 0 is going to be the result of 0 squared plus 3, which is just 3. For the next one, I now look at taking h of negative 2. Well, negative 2 satisfies the first of the inequalities because negative 2 is smaller than negative 1. So in this case, I'm going to have h of negative 2 being negative 3 times negative 2 plus 6. So give me the value of 12. All right, next up, let's move on to h of negative 1. Negative 1 is going to, again, satisfy the middle inequality because negative 1 is less than or equal to negative 1. So because of that, I'm going to use the middle piece. H of negative 1 is going to be negative 1 squared plus 3, which calculates out to a 4. And then finally, we're going to look at finding h of 6. In this case, the x number is 6. 6 is greater than 4, so I'm using this piece of the piecewise defined function. And I always get the value of 5 for any x's that are greater than or equal to 4. So in this case, I'm going to get the value of 5. All right, so that's how we evaluate piecewise functions. Again, we take the x number inside of the function notation, find out which of the inequalities is true, and then use that piece of the function to find the calculated value. Remember, again, we're evaluating a function, so we're only going to get one output for an answer. We can't get multiple values out of an input for a function. It violates the definition. All right, now let's talk about graphing a piecewise function. When you graph a piecewise function, you want to divide it into the two different regions that are being specified. So for starters, we're going to get a function value or a y value of negative 3 between negative 3 and negative 2. What that means is that we're going to have a value of negative 3 on this interval here. It's going to be an open circle because of the greater than negative 3, and an open circle there on the negative 2 because it is strictly less than negative 2. Now for the middle piece between negative 2 and positive 3, it's the function y equals x. Thinking back to the previous note quiz, that's just that diagonal line, and it's going to go from negative 2 with a filled in circle because of the equal sign, straight through negative 1, 1, 0, 0, 1, 1, and go all the way over to 3 with now an open circle because of the open circle right there onto 3. And then finally, for this last piece, it's going to be negative x squared plus 9, and that's for anything greater than or equal to 3, which is right of 3. And so if you actually do stick a 3 in there, you get negative 9 plus 9, which is 0. So you're going to have this piece here being a filled in dot, and then you're going to get a little piece of a parabola going this way at the end. And that is the graph of that piecewise defined function. Again, it's constant between negative 3 and negative 2. It's defined to be x between negative 2 and positive 3. And then it's that little piece of the parabola for values that are right of 3, including 3. All right, let's move on to the next page. In the next page, we're going to talk about what's called the average rate of change, and that's just our calculation of slope. Be very careful to make sure that you follow all of the signs in your calculation. So for the first problem, on the interval from negative 5 to negative 3, substituting everything in, we're going to have f of negative 3 minus f of negative 5 divided by negative 3 minus a negative 5. Again, good idea to put all the signs in here so that we see what we're getting. Now, f of negative 3 means we're sticking negative 3 in place of x. So negative 3 squared is 9, times 3 is 27, plus 2 more makes 29. So that is 29. F of negative 5 is negative 5 squared, which is 25, times 3 makes 75, plus 2 more makes 77. And then down below, we've got negative 3 plus 5 when you have the minus of a negative. We now take a look at what 29 minus 77 is. And 25 minus 77 is negative 52. Divide that by our denominator, which is just a 2, and we end up with negative 26 for that average rate of change. So the slope of the line segment between those 2 points would be negative 26. All right, now let's take a look at the next one. We'll do that one in black. That's going to be f of 1 minus f of negative 1 divided by 1 minus a negative 1. Plugging 1 into our function, 1 squared is 1, 3 times 1 is 3, plus 2 makes 5. So that's 5. Now if we find f of negative 1, we're going to get the same result because negative 1 squared is 1, 1 times 3 is 3, plus 2 makes 5. And our denominator is just 1 plus 1. So we get 0 over 2, which of course just divides out to make 0. So we have a rate of change of 0 for that interval and a rate of change of negative 26 for the top interval. And again, we're just calculating the slope between those 2 points. All right, now we're going to talk about some other characteristics of functions. And we're going to talk about increasing and decreasing. When you answer these questions, you're always going from left to right, following the x-axis. So you'll notice that the function is increasing when it's going up. It starts going up here at negative 2, and it extends forever. So it's going to be increasing from negative 2 to infinity. We're going to use interval notation with a parenthesis on the infinity. And there's a lot of controversy about whether or not you include square brackets or use round parentheses. We're going to use parentheses here because that's how I was taught these things. Now let's focus on decreasing. Decreasing is when you're going down. And you notice that starts here at the far left and goes all the way up until you reach negative 2. So that interval is going to be from negative infinity to negative 2. And then you'll notice that constant would be being flat. And this graph is never flat. This graph is always curving and changing. So there is no intervals where it is constant. It is possible to have a graph that does that. If you think back to the piecewise on the previous page, it did that for a while. But again, here, we're looking at when things are going up or down or staying the same. And again, we always use the x values to answer these questions using interval notation. All right, so now let's take a look at another example of that same idea. You will notice here that this function first starts off decreasing, and it's going to continue until we reach negative 1. So decreasing is going to be from negative infinity to negative 1. And then you'll notice that it goes up for a while, and then it starts decreasing again from 0 to 1. So we use that union symbol, and it's going to be from 0 to 1. Now let's look at the increasing. The increasing is going to occur from here, starting at negative 1 up to 0. And then later on, the increasing starts here at 1 and just happens forever to the right. So that's going to be from 1 to infinity. And you'll notice that we have our interval basically chopped into 4 pieces. We have the negative infinity to negative 1, the negative 1 to 0, the 0 to 1, and then the 1 to infinity. Now we're going to talk about what are called extrema. and extrema are basically the maxes and mins, the high points and low points. And they're relative because we're not looking at the overall picture, we're looking at what happens nearby. So the idea is that nearby here, this point here is a minimum, locally speaking. So that is going to be our relative min, and we can use ordered pairs. It's usually the best way to do this. So it's going to be -1, comma, -2. And again, that's an ordered pair. That is not an interval. So we don't want to use union symbols because that would be abusing notation. You'll notice if we look straight to the right across, there's another place where we have a relative min right here. So that's going to be at the point 1, comma, -2. And then finally, if you look up at the top part of this right here, we have a local max. And that happens to be at the origin 0, 0. Again, just to stress, these are points. These are intervals. Very different things that look the same notation-wise. All right, so that right there is how we look at increasing and decreasing and max and mins. Now let's move on to difference quotients. And the idea here is to continue getting us ready for pre-calculus, which most of us are going to take, or even just regular brief calculus, one of those two classes. So with function notation, you can either build the piece together and plug it all together to build your difference quotient, or you can just plug everything in from the start. And I'm kind of like to do it the second way, which is to put everything together as we go. So here we go. We are going to find f of x plus h minus f of x all over h. And we saw in the previous note quiz, number 5, that when you find f of x plus h, you put x plus h where all of the x's are. So that's going to be x plus h quantity squared minus 4 times x plus h plus 2. Now this formula has a minus in it, and then we subtract away the entire f of x formula, which is x squared minus 4x plus 2. And this whole thing is sitting over top of the h. Next thing to do is to use FOIL to multiply this out. That's x squared plus 2xh plus h squared. Now we distribute. Minus 4x minus 4h plus 2. Once again, distribute. So we've got minus x squared plus 4x minus 2. All sitting over top of the h. Next up, we will cancel down as much as we can. You will notice here, I can cancel out those x squareds. I can cancel out those 4x's, and I can cancel out those 2's. Everything that's left has at least one h inside of it. So I'm going to factor out that common h. When I do that, I'll have a 2x in the first term, a plus h in the next one, and a minus 4h. Sorry, minus 4. There's no h after I factor it out. And again, that's still sitting over top of h. Then, of course, the last step, cancel out those h's, and you're left with your final answer, which is 2x plus h minus 4. And again, if you go on to take calculus or pre-calculus, you'll see a useful application of this in a future class. For the next problem, I'm going to do more simplifications. All right, so we have 2 more difference quotients to take a look at. We're going to take a look at a square root example and then a rational example. So once again, we're going to use that same formula as before. And that formula, just for recap purposes, is f of x plus h minus f of x all over h. So for this one, it's going to be 6 times the square root of x plus h minus 6 square root x over h. And again, we want to simplify this down. So what we're going to do is rationalize our numerator. We're going to multiply the top and bottom of this fraction by the conjugate, which is going to be 6 square root x plus h plus 6 square root x in both the top and bottom. All right, and once we rationalize, we're going to see a lot of nice things happening. First of all, 6 times 6 makes 36. The square root of x plus h times another just makes x plus h because the square roots cancel. Then on the outside, we're going to get plus 36 square root x plus h. On the inside, minus 36 square root x plus h. And then for the last, that's minus 36. And a square root of x times a square root of x just makes plain x. Down below, I've got h times that 6 square root x plus h plus 6 square root x. Upstairs, you will notice that these two big things in the middle, they're going to cancel out. Then I can distribute. I'm going to have a 36x plus 36h minus 36x over top of h times that square root thing again. And you will notice, like the previous problem, those x's are going to cancel out. And then the 36h over h, I can have those h's cancel out. And then we're going to go for it. You will also notice that I can divide these 6's into that 36 and get just plain 6. So my final answer, when it's all said and done, is going to be 6 divided by the square root of x plus h plus the square root of x. And that is the simplified difference quotient for this problem here. All right, now let's do the same thing for the next problem. So for review purposes again, our difference quotient is f of x plus h minus f of x all over h. So that's going to be 12 over x plus h minus 12 over x all over h. You're going to notice that we need to subtract two fractions here, so let's get common denominators. That's going to be x and x plus h. Let's kind of write that off to the side. So in the first one, we're going to multiply the top and bottom by x. And in the second one, multiply top and bottom by x plus h. And while we're at it, let's make that an h over 1. So upstairs, I'm going to have 12x. If I distribute, I get a minus 12x minus a 12h. That's still sitting over top of x times x plus h. And now when I multiply and flip, I'm going to have a 1 over h. Again, we're multiplying by the reciprocal. All right, canceling out what we can. The 12x's cancel out. And you'll also notice that those h's will cancel out. So my final answer here is going to be negative 12 divided by x times x plus h. And that's the simplified difference quotient for this problem. All right, so again, that's how we work with difference quotients. We substitute everything in, do careful algebra to distribute everything, and carefully cancel out whatever we can. All right, so let's move on to the next page. The next page is going to have us looking at adding and subtracting functions. There's two different ways to find these. In my opinion, the easiest thing to do is to find the individual ingredients and put them together. So first up, if I'm going to find f minus g of 6, that's really f of 6 minus g of 6 by definition. F of 6 is just plugging a 6 into the x in the f function. So that's negative 7 times 6. The minus is part of the formula. And then g of 6 is the absolute value of 6 plus 2. So that's a negative 42 minus an 8. We're going to get a negative 50 for that one. All right, let's move on to the next problem. We now have multiplication. This is equal to f of negative 3 times h of negative 3. That's supposed to be an eraser. That is not an eraser. There we go. So again, f of negative 3 times, I don't know why it's acting weird like that. You want the white eraser. Times, why is it doing that? That is an error on the iPad. So let's see what we can do. All right, so again, times, and I just want a pen. So it's gonna be times G, not G, it's H. See how flustered you can get when your iPad starts acting up on you? H of negative 3. All right, so f of negative 3, again, it's just us plugging it in. So that's negative 7 times negative 3. That answer is multiplied with h of negative 3, which is 1 over negative 3 plus 3. And you will notice that that is not possible. You cannot divide by 0. So this is just undefined. We can't do it. And what that really means is negative 3 is not in the domain of h, and therefore it's not in the domain of f times h either. All right, next up we have a little addition problem. G plus h of negative 5 is g of negative 5 plus h of negative 5. G of negative 5 comes from plugging negative 5 into the absolute values. So that's the absolute value of negative 5 plus 2. And then h of negative 5 is 1 over negative 5. Oh, lost the pencil there. There we go. Negative 5 plus 3. The absolute value of negative 5 plus 2 is just the absolute value of negative 3. So that's a 3. And then we're going to have 1 over negative 5 plus 3. That's negative 1/2. So that's 6 halves minus 1/2 makes 5 halves. So that's the value of that function. And then finally, can't erase that little thing that's there, so we'll go over top of it in black. We're going to have f of 4 divided by g of 4. F of 4, again, we're just substituting in. So that's negative 7 times 4. G of 4 is the absolute value of 4 plus 2. So that's a negative 28 over a 6, which is just negative 14 over 3. So negative 14 over 3 is the value of that function there. So again, function composition, not composition, but arithmetic, it's pretty easy. You can just find the individual parts and then build it together by either adding, subtracting, or dividing and multiplying. Or, again, you could build functions as well, like we're going to do in the next example, and then plug the number into the resulting function that you built. All right, so let's move on to problem 19. Problem 19 is us building a function from two given functions. They want us to find r minus p of x. So by definition, that is r of x minus p of x. So in doing so, we're going to just put those two formulas in place. So the r of x formula is negative 3x. The minus is part of our new function. And then the p of x is x squared plus 2x. So that's really a negative 3x minus x squared minus 2x when you distribute. So that's negative x squared minus 5x. So the idea here is we built a brand new function using two given functions. And it looks like there's a divide line there. I'm not sure why, but it's in our video. So anyways, our function that we built is negative x squared minus 5x. Now let's talk about domain. And again, remember, domain is about restrictions. If you think about it, you can evaluate this function for any number x that you want to, because all it's doing is squaring and multiplying and subtracting. Going back to the original ingredients, you'll notice that r of x does nothing more than multiply by a negative 3, and p of x does nothing more than squaring and adding. And then putting that together, no restrictions. So therefore, it's all real numbers. No restrictions on what x's you can use. All right, let's move on to the next page. The next page is to build another function. This time we're going to build f of x divided by g of x. So f of x divided by g of x is literally f of x divided by g of x. If we put those two pieces together, we have 3 times x over the square root of 5 minus x. So that's the function that we get when we build. The more interesting question is the domain. Remember that we can never divide by 0, and we can't take the square root of negatives. So therefore, we need to have this 5 minus x to be strictly greater than 0, which means that negative x is greater than negative 5, or x is less than 5. So we can only use values of x that are less than 5. So that domain is going to be from negative infinity to 5, excluding the 5. All right, now we're going to talk about what's called function composition. And function composition is all about putting one function inside of another function. Again, it's another way to put functions together. So when you're working with functions and working with numbers, best thing to do is always work from the inside out. So in this problem here, we first want to find g of 3 and get an answer, and then take that answer and substitute it into f. So g of 3, if you look at it, is the square root of 3 times 3, which is just going to be the square root of 9, which is going to be a 3. But we're not done, because now we got to take that 3 and substitute it into the f. So we're going to get 3 cubed plus 4 times 3. And that's going to be 27 plus 12, which makes a total value of, looks like 39. So 39 is the result of that composition. For the next one, you will notice it's not written the same way. It's written as f of h of negative 2. So that is rewritten as f of h of negative 2, like this. We're just basically putting nested parentheses. We can now find h of negative 2. That's 5 times negative 2 plus a 2. So 5 times negative 2 is negative 10, plus 2 makes negative 8. And again, we're not done, because now we need to go in and... I didn't do that right, did I? Let's see here. No, that is right. Negative 2 just makes that thing really big, but here we go. So that's going to be a negative 8 to the third power plus 4 times a negative 8, which is pretty big. So let's see here. We're going to get a negative 8 cubed minus basically a 32, which would be negative 544, which is a really big answer, but it is what we get. So negative 544 is our answer. All right, now down below here, we're going to continue the same process. This time around for number 23, we're going to find h of f of negative 2. You notice that the roles of the functions have been reversed, and therefore we're going to get probably a different answer. So we first calculate f of negative 2. That's a negative 2 cubed plus 4 times a negative 2. Negative 2 cubed is negative 8. Take away 8 more is negative 16. And then h is going to give us 5 times that negative 16 plus a 2. So that's going to be negative 80 plus 2, and we get a negative 78. And then finally, for the last one, we're going to calculate h of 1. Well, h of 1 is 5 times 1 plus 2. So that's h of 7. Then h of 7 is 5 times 7 plus 2. And that's going to be 35 plus 2, which is 37. So that is the different values for those function compositions. Again, you just do the inside parentheses first to calculate your answer. All right, let's move on to the next page. The next page has us find compositions of functions, and the result is another function. So we're first going to find p of n of x. So p of n of x. That translates into p of n of x, like so. All right, next thing to do is replace the n with the formula they gave us. So that's really p of x plus 2. And then what does x plus 2 do? It gets plugged into the p. So that's going to be x plus 2 squared plus 3 times x plus 2. For everything out, that's x plus 2 twice. So that's x squared plus 2x plus 2x again plus 4 plus 3x plus 6. Combining my like terms, that's x squared plus a 7x. And then we're going to have plus 10. So x squared plus 7x plus 10 is our answer. And again, the idea is that we put one function inside of another function to create another function, and that's the result. The domain, we have to look at the ingredients we're using. Since we can add anything to 2, no restrictions are coming from the n. We can square and add 3 times anything we want, so no restrictions come from p. Putting them together, no restrictions on that either. So therefore, our domain is all real numbers. All right, now let's move on to the next problem on this page. Once again, we are going to build a composition. This time they want q of p of x. So q of p of x, and let's actually not skip that step there. That is q open circle of p of x. So again, that is q of p of x. What I'd like to do next is replace the p formula with what it was. So that is q of x squared minus 5x. And then we're going to put that into the formula in place of the x. So I'm going to draw a little arrow here and show that this is going to go into the x's in the q formula. So that's going to be 1 over, and again, the x squared minus 5x is replacing the x, and the plus 6 is already there, and we get a brand new function, 1 over x squared minus 5x plus 6. So that's the result of the composition. And then we're going to take a look at our denominator, because we know we can't divide by 0. So we're going to set our x squared minus 5x plus 6 equal to 0. We can solve by factoring. That factors into x minus 2, x minus 3 is equal to 0. So x is 2, and x is 3 is the two solutions. However, this is a domain question. So we don't want 2 and we don't want 3. Those are both bad numbers that we're trying to avoid. So our domain is going to be everything else except for those two bad numbers. It's going to be from negative infinity up to 2, union 2 to 3, union 3 to infinity. Again, it's the whole number line, but now two numbers punched out of it. All right, now let's move on to the final page of this note quiz. And that final page has us working backwards. We're trying to take a resulting composition and find out the two ingredients that were put together to create it. Now what you want to do here is first realize that answers aren't unique. There's different ways to do these. But for us, we're going to try to make it as simple as possible. For me, it looks like somebody stuck an x plus 1 into an x squared. So the inside is the g of x. So that's going to be x plus 1. The outside is the f of x. So therefore, it's going to be an x squared. So in other words, somebody put an x plus 1 inside of the x's in the x squared formula. Now let's take a look at the next one. Similar idea. The inside is the g of x, so that is 2x minus 9. And it looks like somebody stuck a 2x minus 9 into a cube root function. So f of x is the outside, the cube root function. And then finally, for the last one, it looks like somebody stuck an x plus 7 in a denominator. So that x plus 7 could be our g of x. And our function then would be 5 divided by x. And again, if you stuck an x plus 7 in place of the x, you would get the answer that we started off with. So that right there is composition of functions, and it's really important to make sure that you practice these to get really good at them because they play a very large role in the second part of this course, and they play a very big role in pre-calculus and classes that go beyond that, such as calculus.